Good morning, everyone. Thank you for joining us today. When you sit down at your computer, what really defines your experience? It's not the deep down stuff like the kernel scheduling processes or how the file system manages bytes. No, it's the applications. We live and work inside applications. They're the digital tools we use for everything: writing, designing, analyzing, connecting. So today, we're taking a deep look at computer application systems, the very programs that turn our ideas into reality. Just think about your day-to-day. The moment you open your email, compile some code, put together a presentation, or even just browse the web, you are living in the world of application software. These aren't just random programs. They are highly specific, purpose-built digital instruments. And each one is designed to do something that you, the user, actually need to get done. They're quite literally the entire reason we bother with computers in the first place. And this quote just nails it, doesn't it? If the system software, your operating system, is the brilliant conductor making sure the whole orchestra is tuned and ready to play, then application software is the musicians themselves. They're the ones making the music we actually showed up to hear. You can't have one without the other, of course, but it's the application that delivers that final, valuable performance. All right, let's get into it. So here's our game plan for this explainer. We're going to start with the fundamental split between system and application software. Then we'll get into the apps that basically built the modern office: spreadsheets, word processors, all that good stuff. After that, we'll look at the tools for creation and communication, and then the massive systems that run big business. And we'll wrap it all up with some specialized tools and the big takeaways. Okay, first things first, we have to draw a really clear line in the sand. When you look at software from a high level, you can split pretty much everything into two giant categories. And understanding this split isn't just for exams, it's absolutely key to understanding how our computers actually work. So what is that big difference? We're talking about two totally separate layers of software. How do we draw the line between the stuff that keeps the machine running and the stuff that we, as users, actually use to get work done? Well, here's a great way to think about it. Your system software, that's your OS, your device drivers, all that, it's like the government of a city. It builds the roads, runs the power grid, provides clean water, it gives you the essential infrastructure. It doesn't build a car for you or write a book, but it creates a stable, functional environment where all of that stuff can happen. Application software, on the other hand, is the actual building you construct on that land. It's the factory, the office, the library. It has a very specific purpose that gives you direct value. It does the work. So that analogy brings up a really fascinating technical question. If the app is just a building and the OS is the government, how in the world does something like Microsoft Word get a letter from your physical keyboard onto your screen? Well, the short answer is it doesn't. Not directly, anyway. What's really happening is this elegant chain of command, and it's all handled through the operating system's API, its application programming interface. The application is completely separated or abstracted from the hardware. So when you press the A key, Word doesn't care if you have a Dell keyboard or some fancy mechanical one. It just makes a generic request to the OS API saying, hey, the user pressed A. The OS, which does have the specific driver for your hardware, takes that signal and says, got it. Then the app says, okay, now please draw an A at these coordinates. And the OS uses its graphics API and the GPU driver to actually put the pixels on the screen. This abstraction is everything in modern computing. And that right there, that deep, deep dependency on the OS's specific API, that is exactly why software isn't universal. A program written to talk to the Windows API with its unique set of rules and libraries literally speaks a different language than macOS, which has its own API. And that technical reality is what creates the Windows-compatible and Mac-compatible software worlds we all live in. All right, let's move up the stack to the applications that completely change the nature of work itself. These are the tools of the knowledge worker, the digital heirs to the typewriter and the ledger book. They basically invented modern office productivity. This is such a great story in tech history. Back in the late 70s, big business thought PCs were just toys for nerds. So what was the one application, the one program so powerful, so revolutionary, that it forced the entire business world to put a PC on every desk? The answer was VisiCalc. It came out in 1979 for the Apple II, and it was the very first electronic spreadsheet. And its genius wasn't just the grid. It was the idea that a cell could hold a formula that was dynamically linked to other cells. This sounds so simple now, but back then, creating instant logical relationships between numbers was like discovering fire for the finance world.
Just look at this evolution. Before VisiCalc, you had accountants working on huge paper ledgers. You could take a week to build a financial model. And if the boss came in and said, hey, what if our costs go up by 3%? Well, that was another week of recalculating everything by hand with a pencil and a calculator. VisiCalc changed a week of work into 5 seconds. You just changed one cell and the entire model updated instantly. It was a total game changer. Later, Microsoft Excel took over with more powerful tools, and then Google Sheets moved the whole thing to the cloud, giving us the real-time collaboration we expect today.
Speaking of that move to the cloud, let's look at the word processor. For years, Microsoft Word was the unchallenged king. It was this powerful desktop program. But then Google came along, and they didn't just try to add more features, they changed the entire game. How'd they do it? Google Docs was built from the ground up as a cloud-native web app, and that introduced 2 revolutionary ideas. First, it completely solved the version control nightmare. No more report_final_v3_real_final doc. Your document was now a single, central thing you could get to from anywhere. But second, and this was the really mind-blowing part, it allowed real-time collaboration. You could have multiple people typing in the same document at the same time and see their changes happen live. It turned writing from this lonely one-after-the-other process into something dynamic and truly collaborative. Okay, moving on. Let's talk about the apps that let us share ideas and create content. These are the tools that have basically erased physical distance, sped up business, and totally reshaped how we interact and create. Let's start with the technology that makes almost all of our modern voice and video calls possible. What exactly is VoIP, and what kinds of apps did it unleash on the world? VoIP stands for Voice over Internet Protocol, and what it does is pretty cool. It takes your voice, digitizes it, chops it up into little data packets, and sends it over the internet instead of an old-school phone line. Skype was the one that really brought this to the masses, and suddenly you could call someone across the world for free. More recently, of course, Zoom perfected it for business use, and it became the absolute backbone of the pandemic-era work world. These apps didn't just change how we chat. They are the engine of the global remote work economy. So while Zoom was changing the formal meeting, another app, Slack, was totally upending the constant informal chatter that happens between meetings. It basically declared war on internal email. Slack's big insight was recognizing that internal email is actually a terrible way for teams to work together. It's private, it's clunky, it's impossible to search, and it creates those awful reply-all nightmares. So Slack introduced the idea of channels, basically ongoing chat rooms organized by topic or project. All of a sudden, instead of a cluttered inbox, you had this shared, transparent, and searchable hub for all team communication. It made everything faster, more informal, and way more collaborative. Okay, let's switch from communication tools to creation tools. For more than 30 years, one application has basically owned professional photo editing, Adobe Photoshop. And all of its incredible power comes from one single brilliant idea. And that idea is layers, layer-based editing. It lets you stack all the different parts of your image, pictures, text, color adjustments, effects, like they're on transparent sheets of plastic. And the key, the magic, is that you can edit each layer on its own without permanently changing the others. We call this a non-destructive workflow. You can change the text without messing up the background. You can tweak the colors without touching the original photo. It gives you incredible control and flexibility, and it's so fundamental that the name of the program is now a verb. So, just like Photoshop changed the photo darkroom forever, another type of software did the same thing for the film editing room. Let's talk about the nonlinear editor, or NLE. Before NLEs, editing a movie was a physical, brutal process. Editors would literally take a razor blade to strips of film and tape them together. It was slow, it was permanent, and you had to do it in order. A nonlinear editor, like Adobe Premiere Pro, changes everything. It digitizes all the footage, and once it's data, the editor can instantly jump to any frame of any clip. They can try a million different versions, all non-destructively. This completely democratized video production and directly powered the rise of the creator economy you see on YouTube and TikTok. All right, now for what is probably the single most used app on any computer today, the web browser. Its job has changed so much over the years, from being a simple window to the web to, well, something much, much bigger. Yeah, the first web browsers were exactly that, browsers. They were just simple viewers for text and images. But today's browsers, Chrome, Firefox, Safari, they are unbelievably complex application platforms.
For all intents and purposes, they're mini operating systems. They have their own task managers, their own security systems, and these incredibly powerful JavaScript engines that can run complex code almost as fast as a native app. This evolution from a simple viewer to a powerful platform is what made the entire software as a service or SaaS revolution possible, letting us run amazing apps like Figma or Google Docs right inside a browser tab. Now, beyond the tools that we use every day, there's this whole other universe of massive software designed to run entire global companies. These things are like the digital central nervous system for modern business. And in that world, you hear two acronyms thrown around all the time: ERP and CRM. They are the two giant pillars of enterprise software, but they do very different things. So what's the actual difference between them? This table breaks it down perfectly. An ERP, that's Enterprise Resource Planning, focuses on the back office, all the internal stuff: finance, HR, supply chain, manufacturing. Its main goal is to connect all these different parts of the business into one giant database to create a single source of truth for the whole company. A CRM, on the other hand, Customer Relationship Management, is all about the front office, anything that touches the customer: sales, marketing, customer service. Its goal is to give the company a 360-degree view of the customer. So ERP is inward-facing, CRM is outward-facing. All right, we're in the home stretch. For our last section, let's touch on a couple of highly specialized apps, and then we'll pull it all together and figure out the big takeaways from all this. Let's start with a type of software that isn't about creating or communicating, but about protecting. What is the fundamental job of an antivirus program? The best way to think about it is as a dedicated security guard that's always on duty on your computer. It runs constantly in the background, monitoring everything. The old school way it worked was by looking for signatures, basically digital fingerprints of known viruses. But malware changes so fast now that that's not enough. So modern security software also uses what we call heuristics. It looks for suspicious behavior, like a program suddenly trying to encrypt all your files or talk to a known bad server, and it steps in to stop the threat, even if it's a brand new virus it's never seen before. And finally, let's look at education. The whole mobile app boom created this new kind of educational software that feels more like a game than a textbook, and Duolingo is the perfect example of this change. Duolingo's crazy success is all about one thing: gamification. It took the chore of learning a language and turned it into a fun, addictive little game. It uses all these psychological tricks to keep you hooked: points, daily streaks, leaderboards to compete with friends. But under the hood, it's actually pretty smart. It uses AI to personalize the lessons, figuring out what you're good at and what you struggle with, and then adapting to help you learn more efficiently. So we have covered a ton of ground here, from the first spreadsheets to the cloud platforms and massive enterprise systems running the world today. After all that, what's the one big idea, the key takeaway you should leave with? Here it is. This is the bottom line. Application systems are that final critical layer where a computer's power actually becomes useful to a human being. They are the interface where our goals, our ideas, our intentions get translated into actual digital action. They are what make all the power of the hardware and the OS tangible and valuable to us. And that leads us to one last thing to chew on. The trend is obvious, right? Apps are becoming more connected, smarter, more collaborative. And that raises a really fascinating question. Are they moving beyond just being passive tools that we command? And are they starting to become intelligent partners that can anticipate what we need and help us do things better? It's definitely something to think about. Thank you so much for joining me for this deep dive into computer application systems. Be sure to subscribe to our channel, Tech, AI, and Beyond, for more deep dives into the technology that shapes our world.